Okay, this is Jack Jackson. In this video, we're going to look at an example of using average or finding the average value of a function. Of course, to find the average value of a bunch of isolated discrete numbers, we just add those numbers up and divide by how many we have. That's called the mean, or it's sometimes called the arithmetic mean, or just the average. But how do we average infinitely many numbers? Well, we've seen in an earlier video that the average value is found by taking the integral of the function over that interval and divided by the width of that interval. So if you want to integrate, let me just put a recall here. The average value of a function f, let's say of x, on an interval, let's say from a to b, is given by the following. Okay, let's do this. It's given by, you do that integral and you multiply by 1 over the length of the interval, which is b minus a. And this is f average. Okay, so, and you can look back at an earlier video to see an explanation of that back in probably a couple playlists back. Now, the population of a certain region is growing at a constant relative rate or percentage rate of 6% per year. So it goes up 6% one year, and then it goes up 6% the next year, 6% the next year. Its current population is 356,500 hitting that time. Let's call it now time 0. What's the average population over the next 15 years? Now, since the population is growing at a constant relative rate, percentage rate, that makes the population an exponential function, which is the initial population times 1 plus the rate to the t power. The rate is 0.06, so that is 1.06 to the t power. When you do this, your rate and your time must have complementary units, actually reciprocal units. So if your t is measured in years, if your rate is a percentage rate per year, of course you're going to immediately convert it to a decimal instead of a percentage. So it's just a decimal per year, and then the t must be measured in years. That's a basic thing from algebra. Check out one of my videos on exponential functions if you want to see a little bit more explanation of that and a little bit more applications of that. But if we plug in our particular numbers, we know that our initial population is 356,500. That was what was given as the initial population at time 0. Notice when this base works out to be 1.06. If you plug in t as 0, 1.06 to 0 is 1, times that gives you at time 0, that's our population. Now, our p average over the 15-year period is from 0 to 15. That's 15 years from now. It starts now at time 0, ends at time 15. You do 1 over 15 minus 0 is 1/15th, and then you have this function here. I just brought the 356,500 out front, divided by 15, reduce the fraction by canceling some 5s there. And then I'm integrating from 0 to 15, 1.06 to the t. Let me go ahead and do it exactly, which is, well, there's no reason to do it exactly. We just need a decimal approximation, so you might as well pick up your calculator, do function integrate. You're going to need to pick up your calculator to do some decimal approximations anyway. So just do your function integrate, math 9 on the calculator, or just type it in like it looks here on the calculator for a newer operating system or on a TI Inspire. The older 84s look like this, and we get that many organisms, whatever this is a population of. some kind of organism. Maybe it's people. 59,626.8. Well, let's say 59,627 people is the average number of people. Or maybe this is not people. Maybe that we're talking about rabbits. Who knows? Whatever kind of organism we're talking about, that's how we get it.